What is boilerplate elimination? Is boilerplate really all that bad? And how can eliminating boilerplate help us? Let's take a look. If we want to write a class style object in Python, well, we need to write a lot of boilerplate. Here, all this class does is it supports double equals and it can be put into a set. And we had to write a repr so we could print it out into the screen nicely. We had to write an EQ. We had to write a hash. We even wrote a property here just to make this thing, to give a little bit of additional guidance that this thing is immutable. That's a lot of code to write to do very little interesting work. And we may desire to eliminate this boilerplate, to reduce this boilerplate, because we're like, look, I have other more important things to worry about right now. I don't need to be writing 8 lines of code to really accomplish nothing that's really material to my business case, to my use case. And so we might use a collections.name tuple to reduce all of that to 1 import and 1 line of code. Or we may even use a dataclasses.data class to reduce this to 1 import and 3 lines of code. And in exchange for that 1 import and those fewer lines of code, we get all of that additional mechanism for free. That's a pretty good deal. I got at least 10 to 15 lines of code for free without having to painfully write it out line by line myself. But, this only really makes a difference if I'm in a rush, if I'm rapidly prototyping, if I need to get something in front of somebody very quickly. 15 lines of code is not that much code to write. And so when you think about the boilerplate elimination tools that you have in Python, here's what I want you to think about. Think about them as a step along an escalation pathway. In other words, when we start writing our code, we need to show something to somebody really quickly to prove the idea. So we may use the simplest entities that we have available to us, like lists of tuples. Not even any custom class, we just use the built-in types. And we write some use code to interact with these lists of tuples. But we quickly will discover that the ergonomics of that are very poor. We need to know what the order of the entries are. And as this code grows, and as the distance between the definition of this and the use of this grows, it may be harder for us to know, did this unpacking work correctly? Did we get the order right? Or what does this square bracket 0 and square bracket 1 actually mean? Thus, we may, in a code commit, introduce a name tuple. And we might not even use it. We might just add it in there and say, okay, I'm going to come back to this in a moment. This is very non-disruptive because we're now thinking, can I improve my code on my schedule? Can I make small targeted improvements when I have the availability and the time? And we absolutely can. Because after introducing our name tuple, we could apply it to our entities. And we don't have to change any other part of our code. We can leave that intact. By introducing this name tuple, we are not requiring that we go and rewrite a bunch of code ahead of time. However, when we have the time and the patience, we then may choose to rewrite this code to support the named lookup. And once we've rewritten all of our code to support this named lookup, we then may say, okay, this allows me to add fields, where previously the unpacking or the indexing may not support the addition of fields or may create some other errors depending on where we add those fields. So now we might say, okay, now I'm ready to add fields. Once I've done that, I might say, you know what? Now I might not want to provide all the fields on instantiation of these types. I might want to have defaults, and I might want to even check that some of the fields that are provided are constrained to certain values. And you can see I'm slowly escalating the complexity of this code as my need arises, and I'm minimizing the amount of work I have to do before I actually need it. That's what boilerplate is. Boilerplate is a bunch of work that you have to do up front when it wasn't even that valuable for you to do it right then and there. Well, that work that we had to do up front that we eliminated might eventually be valuable, and we may eventually step toward it. A next step along the way might be to take that name tuple and to turn it into a data class, especially if we need to support mutability. Obviously, the collections.name tuple, by virtue of being a tuple subclass, is immutable. Or in order to support things like additional parts of the protocol, a call, or to customize parts of the protocol EQ. We could do that on a collections.name tuple, but it just gets clumsier and clumsier as we go. Once we do that, we may say, you know what? At this point, I'm invested enough, I have enough time, why don't I just implement a fully fledged class and then I write all the boilerplate. But you can see that this was materially better than writing all the boilerplate up front, because as we iterated through this code, we were able to take our time to determine, is this valuable in the first place? Is this something I want to keep using? Is this the entity that I want or not? Should I refactor my code? And we can write the boilerplate when we say, okay, now it's actually valuable for my use case, and use this escalation pathway, these boilerplate elimination tools, to prevent us from writing a lot of boilerplate if we're not certain if that's even going to be used. In addition to the collections.name tuple and data class, we also have an enum, which automatically generates the boilerplate for an enumerated type. We have a functools.total ordering, which allows us to implement all of these methods, all of the comparison methods, with only needing to implement 2 of them. We even have a contextlib.context manager that allows us to implement the enter and the exit parts of the context manager protocol in a generator without having to even remember what the exit protocol's arguments are. Is boilerplate that bad? No, but boilerplate too early in the process is annoying and gets in the way of proving an idea we're trying to show somebody. Eliminating that boilerplate, or at least shifting the writing of that boilerplate to once we already know this is the direction we want to take with this code, well, that is definitely a good idea, and this is why we want to use boilerplate elimination tools strategically to control the scheduling of when we write all of that additional detail, all that additional red tape that's necessary to implement a Python object. With that said, you can see we've taken a look at a lot of details related to object orientation, how we might see each one of these concepts arise in our programs. I want to thank all of you for joining us today. In our next session, we're going to take a look at some deeper mechanics of how Python works, things like decorators and class decorators, and to understand when we might choose those and what those might mean in our code. But until then, I'll see you all next time.
Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.